Hey everybody, welcome back to All the Math. That's all the math you need for computer science. This is episode 4 of our linear algebra volume, and we have now reached the matrix, the big daddy of them all. This is the quintessential mathematical object of linear algebra, and we're going to talk about it and explore its depths and learn all the rules for how to deal with it. But as Morpheus would say, no one can be told what the matrix truly is, Neil. You have to see it for yourself. So, without further ado, let's dive into a couple of preliminaries before we hit the matrix proper. So you'll remember we talked in previous episodes about a vector, and I've been drawing it like this, 2, 3, 5, -9. And I've been sort of sweeping under the rug the question of which direction this vector goes, which is going to turn out to be important now that we're dealing with matrices. So what I've written right here is called a row vector, since I've written it that way. I could have also written this, 2, 3, 5, -9, and this is something we call a column vector. I'll often just say col. Now let me just make one little quick point here. I resisted learning these terms when I first learned linear algebra. When I first was told about row and column, I'm like, I'm not going to memorize which one goes across-wise and which one goes tall up and down-wise, because I can see just by looking at the paper which one it is, right? So I'm not going to spend my time learning these terms that other people keep using because it's just obvious when you just look at it, right? Don't do that. Don't make that mistake. Because when you read a math book or a math paper or when you look at mathematical work, you're going to constantly hear references to a row vector, to a column vector, to a matrix with this many columns and this many rows. And you can't, in the heat of the moment, spend time trying to recall to mind which one goes this way and which one goes this way, okay? It's kind of like when you learn how to speak a foreign language, right? You can have your little Spanish-English dictionary with you to learn or to look up the difficult words, the rare words. But you can't be constantly looking up the and, right? Because you just aren't functional in the language at all if you have to do that. There are certain words, the common functional words, that have to be on the tip of your tongue for you to have any fighting chance of understanding what's going on. Then you can look up the rare ones at your leisure, right? Row and column are words for us like the and. So just remember, as soon as you hear row, visualize a long, flat thing. And when you hear the word column, visualize a tall, skinny thing, okay? Now, we're going to be calling these a row vector and a column vector. And notice that when we talk about things like the dot product of two vectors or adding two vectors or anything else, it actually doesn't matter whether it's a row or a column, right? If I have another vector here, z, and I let that be 1, 1, 1, 1, then taking the dot product between x and z gives us, 2 plus 3 plus 5 plus -9. I think that's 1, maybe. And if I take x dot y, that also ends up giving us the dot product 1, right? As long as we're treating them as vectors and not really treating them as degenerate matrices, which is what we're going to start to do in this episode, okay? So in a minute, I'm going to define a different operation of what you can do with a vector depending on whether it's a row or a column, okay? So it's weird. We're a little bit playing fast and loose with the terminology and with the concept. Sometimes we're going to treat a vector just as a vector, and whether it's row or column is just a matter of how you write it on the page. Other times, we're going to be very specific about whether it's a row vector or a column vector, and it's going to matter, okay? And I'll try to be very clear in these lessons which case it is, right? One last thing. By default, you might think that a vector is going to be a row vector. You might think that's sort of the base level vector. At least that's what I thought, right? And that's simply because when you're writing something out, you write left to right. So it just sort of seemed natural that you'd say, I have a vector x which equals boxy, da-da-da-da-da, boxy, right? Sort of seems like row vectors were natural. Actually, it's going to turn out that unless we specify otherwise, the default for us is going to be a column vector. And there are some reasons for that, and you'll see that there are certain operations where it turns out to come up more often and therefore make more sense. But bottom line, all you got to know is that a vector is really a tiny matrix in disguise, and there will be times when we explicitly treat it as either a row or a column.